Okay, in wave mechanics, there are some very important concepts that we need to know. And with these concepts, it will be helpful for us to interpret the high-strength dynamic test data. First is the proportionality of F and V, and then is the elastic wave speed. And third is the definition of the sign of the F and V. And then is the superposition and the separation of the wave. Now we're going to introduce these concepts one by one. First one is the proportionality. About proportionality, we will talk about parameter impedance. The impedance, it has a physical meaning. It means the force that needed to make the particle to move with the unit speed. That is the speed 1 meters per second. How much force is needed to make the particle to move with the velocity of 1 meters per second. That is impedance. And also we use impedance to describe the pile integrity. That is how we evaluate the data in low-strength dynamic test. And we multiply V by the impedance for further calculation with F. That is called proportionality. So let's take a look at the picture. The impedance means F and V, they are stick together, usually before the first peak. We know that F is with the unit of force, it's kilonewton, right? And the velocity is with the unit of meters per second. How do we put the two parameters with different units into one picture and calculate? The reason is that we multiplied V with the impedance Z. So if there is no soil resistance, we should see that force and the velocity, they should stick together until the end of the pile. The reason that they separate is the soil resistance that we are going to discuss later. So first, let's take a look at how we can get the proportionality relationship. Let's observe the movement of a particle on the pile. Usually, the particle is the location where we install the sensors. If we hit the pile head with a hammer force, it will generate a wave going down and go through the particle. The wave speed, we can call it C. Actually, it's Ws. We can call it C. And the stress pushes the particle to move downwards with a velocity of V,